Okay, so in the concluding video, we look at trigonometric identities as distances. In this video, we'll look at cot theta and cosecant theta. I mean, you can look at the other two videos for sine, cos in the first part and tan and secant the second. It will give you an idea where we are going. So again, the same unit circle. We have the co-triangle, which is here. That is 1. And this is sine theta, and this is cos theta. So I need again another triangle, which is, so basically here if I want to get cot theta, right, so my cot theta, if I get cot theta by 1, why by 1? Because that's how the length itself will become equal to cot theta. So cot theta by 1 will be equal to cos theta by sine theta. Okay. So that means the height has to be equal to 1. So if I draw a line, horizontal line, this height y will always be equal to 1. In fact, this equation is y equal to 1. So now if I just extend this, then this is cot theta, right, horizontal. You can also do it here. So this is cot theta, and you will notice that earlier we had tan in next to sine, and cot is of course next to cos, because cos is the numerator. Okay, so this length becomes equal to cot theta. So what can we learn about that? Once we see this, we are basically saying that what are the properties of cot theta, right? So we can see that since it's a horizontal line, when cos theta is 0, it's here. We'll talk about that last. Okay, so we can see that so cot theta, let's say when theta is 90 degrees, right? So cot of 90 will be here. The x value is 0. So cot of 90 is 0, similar to cos theta. Yeah. And as we keep decreasing the angle, so tan was increasing the angle, here is decreasing the angle. So this is my theta. And as I keep decreasing my angle, the line is becoming more and more horizontal. Finally, when it is 0, the lines become parallel and they never meet, right? So cot of 0 basically will approach infinity. It will meet at, well, it won't meet. But basically if it was even a little angle, it will meet at a very large value, and it blows up. So you can see, similar to tan, that relationship that we did with tan is similar. And same way 45 degrees, for example, when this is 45 degrees, this is the same as this. So cot of 45 degrees is equal to 1. That also comes out of it. Yeah. And so if you have again a triangle in which what is given is actually the height, right? So if you have, I haven't completed it, but this is, sorry. If this is 1, this is cot theta, this is angle is theta, right? So you can imagine the same way as we did the tan. Now if I want, what is this length, right? So this triangle is similar to this triangle. In this, I'll just take the first triangle itself. This length is, this triangle is similar to the smaller triangle, and what I want is again hypotenuse. So hypotenuse divided by 1 is the opposite side now, right? So y is equal to 1. This is 1. This is always been blue. Okay, so I want hypotenuse by 1, which is the opposite side, will be equal to, so this is similar to the hypotenuse of a smaller triangle, which is 1 divided by sine theta. So this is giving me secant theta, sorry, cosecant theta. Okay, So let's draw the triangle again. So the triangle we are talking about is of course unit circle, vertical line. This is the triangle of interest. This is 1. This is cot theta, and this is cosecant theta, right? So again the trigonometric identity will be 1 plus cot square theta is equal to cosecant square theta. So this trigonometric identity also comes out from this triangle. And again, if someone gave you the opposite side, let's say they said, okay, this is 100. You have your triangle, and in your triangle this is 100. So then you can just scale the original triangle, and this is theta of course. So then you can say, well, this is 100 cot theta, and this is 100 cosecant theta. So you can also solve questions like this. Now that we understand that there is a triangle with a certain distance. So if you watch part 1, part 2, then part 3 is basically following what we're just completing it. Thank you.